Approximately 1 in 7 people lack access to food and are chronically malnourished. Though current famine statistics are disquieting, recent studies have shown that food production must double to keep pace with the projected increase in population, which will reach 9 billion by the year 2050. An approaching food crisis was predicted as early as the Enlightenment, when philosopher Thomas Malthus observed that the human population rises geometrically, while agricultural production rises arithmetically, creating an inevitable deficit. After 3 centuries, with scarcity looming, the world is still without a feasible solution. To enable food security, production must grow substantially. However, the environmental damage that results from traditionally productive agricultural practices must be lessened. Excluding unrelenting population growth, the current global food supply is already at risk. As a result of decades of unsustainable overuse of aquifers, water tables have fallen. Because conventional farming techniques require excessive quantities of water, a shortage endangers the yield. Global warming, with rises in average temperatures every year, taxes crop production. Temperatures above 34 degrees Celsius cause photosynthesis to slow or cease, causing thermal shock, dehydration, and subsequently decreasing crop volume. The increased global consumption of animal products results in the need for additional animal feed. Consequently, only 62% of crop production is allocated to human food.
To meet demand, instead of more sustainable methods, conventional agriculture is expanding into sensitive ecosystems, like the tropics, whose deforestation has negative effects on biodiversity and augments global warming. These losses, among others, strain an already precarious situation. The need for both productive and ecological approaches is evident. Industrial monoculture farming is the least sustainable, but globally the most popular farming technique. A monoculture is low diversity, producing single crops on a very large scale, with a heavy reliance on synthetic fertilizers and pesticides. Economically, monocultures are practical, as they generate a high yield at low cost. Monocropping, however, leads to soil depletion, dependence on fossil fuels to operate farm machinery, and damage to surrounding populations and ecosystems, attributed to the unintentional dispersion of chemicals and pesticides. One of the consequences of the use of monocultures is soil compaction. Soil compaction results from the overuse of machinery, intensive cropping, and short crop rotations in a variety of different soils and climates. While recognized as one of the most critically destructive environmental impact of modern farming, it is challenging for farmers to detect areas of soil compaction, which immobilizes any treatment that would prevent the worsening of conditions. Oftentimes, the low yield that results from soil compaction is mistakenly attributed to other factors, further postponing resolution. Worldwide, approximately 68 million hectares of land have already been compacted from harvest traffic on farmland. Soil compaction is detrimental because it is difficult to reverse and renders land uncultivable. To decrease the gap between supply and demand, farmland cannot afford to be lost.
Many have recognized that despite their productivity, monocultures cannot sustain future populations. Accordingly, many alternative farming techniques have been tested. One attempt at sustainability involves the cultivation of palm oil, a critical crop that is typically generated by monocultures. Malaysia, the world's largest palm oil producer, is leading the transition to more responsible farming practices. The palm oil industry is presently using its waste for mulching and fertilizer, and farmers have instated zero-burn policies. Cultivation of new land has also ceased, and instead, work is being done to develop previously depleted land. In urban areas, vertical farming is increasing in popularity. The simplest vertical farms are soil-based and operated more like rooftop gardens. The most advanced, however, are building-based, featuring conveyance systems, supplemental lighting, and hydroponic growing systems, which replace soil with more cost-efficient, nutrient-enriched water. Enhancements such as these boost yield and have the potential to feed the population more effectively and for longer term than current industrial practices. One particular vertical farm, Local Garden, a greenhouse of almost 6,000 square feet, was constructed by Canadian cleantech firm Alteris, who claims that their farm supplies 20 times the yield per growing area compared to land farming, with over 90% less water use.
Other attempts to achieve food security and make productivity sustainable arise in the form of aquacultures. Aquacultural farming involves the cultivation of freshwater and marine plants and animals predominantly for consumption. The primary purpose of these aquatic farms is to increase the production or yield to a level above that obtained naturally in a particular aquatic environment. According to the Encyclopedia of Farm Animal Nutrition, aquacultures have become the world's fastest growing food production sector for over a decade, comprising of the cultivation of over 200 different animal and plant species. Standard aquacultural practices have been criticized because, like monocultures, aquacultures can have negative environmental impacts, including the destruction of natural ecosystems and pollutant release. To prevent ecological detriment, more sustainable practices are being investigated. Integrated multi-trophic aquaculture, abbreviated IMTA, refers to the farming of different aquacultural species together. This increases biodiversity while allowing one species' waste to be recycled as feed for another. This decreases eutrophication, or the over-enrichment of minerals, a process that reduces the dissolved oxygen content in the water and is commonly seen around monocultures. Integrated multi-trophic aquacultures therefore have the potential to create balanced systems for biomitigation. One particularly sustainable multi-trophic system exists in India, where farmers raise fish from rice fields. The waterlogged rice fields form an optimal habitat for wild fish, facilitating a symbiotic relationship that increases sustainability and productivity when compared to independent rice or fish farms. Raising fish along with rice is a reliable system that existed in nature before human imitation. The fish keep the rice crop healthier and increase yields, and the fish can then be harvested as well.
While all of these developments improve yield and sustainability, we feel the most viable solution to the impending food crisis is not one of the aforementioned techniques, but an amalgamation of recent terrestrial and aquatic advancements. A system analogous to our ideal solution presently exists, demonstrated by a 4-story produce and fish farm located in the meatpacking district of Chicago, referred to as The Plant. At The Plant, a fish farm and gardens are linked by a 9,000-gallon water circulation system. This almost fully closed aquaponic system, the hybrid of aquaculture, raising fish in a contained system, and hydroponics, cultivation without the use of soil, uses biomimicry to engender a functioning artificial ecosystem. The ammonia-rich waste from the fish, presently 2,000 tilapia, feeds the plants, and the plants clean the water, which is then returned to the fish tanks. Tilapia are used as they don't require salt water, can be harvested in 10 months, and thrive in a confined space. Bacteria present in water filters break down the fish waste, allowing easy absorption by the plant roots, and certain insects help safely control pest populations without the use of hazardous chemical pesticides. The entire system requires almost no input, simply occasional fish food and micronutrients. After the plant's initial success, while simultaneously producing minimal waste, developers began to introduce an anaerobic digester that breaks down organic waste into biogas and material that can be used for fertilizer. The biogas is then converted into energy that provides heat and electricity to the plant, allowing it to produce large quantities of food with a net zero waste output. Though the plant is able to operate entirely off the grid, it remains connected to the public electrical grid as a backup power source, but also to perhaps reroute any surplus electricity back to the public grid. The productivity and sustainability of Chicago's plant is manifest. Vertical farming permits a high yield in a smaller area and is especially advantageous to metropolitan areas. The aquaponics system eliminates any waste products while encouraging sustainability with little to no input. The plant alone can produce enough food to feed approximately 10,000 people. The entire system also generates its own gas and electricity, in unambiguous contrast to traditional fossil fuel-dependent monocultures. We see the combination of vertical farming, hydroponics, and aquaculture as the superlative resolution to the food security crisis, and advocate the expansion of its practice as well as any additional improvements that can be made to the approach.